All right, Chapter 12, Section 1, Matrix Operations. Here we're going to be talking about basic matrix operations. A matrix is just a set of numbers that is listed in a matrix form, where there's just two brackets, and then you have numbers inside the brackets. The first row is called row 1, the second row is called row 2, and then the first row is called row 1, the second row is called row 2, and then you have columns. Basically, numbers are just set up in columns. Sometimes there's variables inside, but most of the time it's just numbers. Okay, when matrices can be added or subtracted, they must have the exact same number of rows and columns. So if you look at this one, for example, notice how this is a 2 by 2 matrix, and we're adding a 2 by 2 matrix. These can be added because they are both 2 by 2. They have 2 rows and 2 columns. When you're subtracting matrices, notice how this is a 2-row 2 by 1, and this has 2 rows 2 by 3, so they cannot be subtracted. When you're adding and subtracting, they have to be exactly the same. What is the rule to add and subtract matrices? When the dimensions, the number of rows and columns of two matrices match, add or subtract corresponding entries. So what does that mean? For example, this is a 2 by 2 matrix and this is a 2 by 2 matrix. So we're going to go ahead and add these matrices. What that means is I'm just going to add this one that's in row 1, column 1 to row 1, column 2. So we just have 3 plus 9 is going to be in that spot, same spot here. And then I'm going to take row 1, column 2 plus row 1, column 2, which is 2 plus 13. And that goes here. Then row 2, column 1, 5 plus row 2, column 1, 5 plus 2 is here. And finally, row 2, column 2, row 2, column 2, negative 1 plus 4 goes here. And that's my new solution. Just go ahead and simplify. So 3 plus 9 is 12. 2 plus 13 is 15. 5 plus 2 is 7. And then negative 1 plus 4 is 3. So that's my solution right there. Very simple. So let's go to the next one. Multiplication. To multiply a matrix by a scale or factor or number, simply multiply each entry from the matrix by that number. Basically, you're distributing if you're multiplying by a scale or factor. So we're multiplying this entire matrix by negative 2. So what I'm going to do is I'm just going to multiply each one inside. You're kind of distributing by negative 2. So it looks like this. Negative 2 times 3. And then I have negative 2 times 7. And then I have negative 2 times 8. Which gives me negative 6, negative 14, and negative 16. Same thing when you're multiplying 4, and this is a 2 by 2 matrix. I'm just going to multiply each term or each number inside by 4. So I have 4 times 12. I have 4 times 9. I have 4 times 6. And then I have 4 times 3. Which gives me 48, 24, 36, and 12. That's my solution. And then one more example. Even it doesn't matter what the matrix looks like. This is a 3 by 1, so I'm just going to multiply each one by negative 5. So I have negative 5 times 13. And then I have negative 5 times 2. And then I have negative 5 times 11. Negative 5 times 13 is negative 65, or negative 60, yeah, negative 65. And then I have negative 5 times 2 is negative 10. Negative 5 times 11 is negative 55. So multiplying by a scale or a factor or just a number. Now use the following matrices in 1 through 3 to add or subtract if possible. So if this is my 2 by 2 matrix that we call A, this is my 2 by 2 matrix that we call B, and this is my 2 by 3 matrix we call C. Now I'm going to perform these operations on those 3. So let's go ahead and try that. So A plus B means I'm going to take 3, 6, 5, 0, and I'm going to add matrix B, which is 12, 7, 5, 9. add the corresponding rows and columns. So 12 plus 3 is 15, 6 plus 7 is 13, 5 and 5, 10, 0, 9, 9. And that's my solution. What if I add B plus C? I have a 2 by 2 plus, so that's 12, 7, and 5, 9, plus 3, 6, 9, 1, 5, 7. Can I do that? I cannot, because this is a 2 by 2 and this is a 2 by 3, so it's not possible. Not possible, or no solution, or whatever you want to call it. Now, subtracting, I kind of didn't give myself enough room here, but let's go ahead and subtract. I'll move this over. Let's subtract B minus A. So I have 12, 7, 5, 9, and then minus 3, 6, 5, 0. If that's the case, and I go ahead and subtract those, I'm just going to subtract each row 1, row 1, row 1, row 1, column 1, row 1, column 1, corresponding part. So 12 minus 3 is 9, 7 minus 6 is 1, 5 minus 5 is 0, and 9 minus 0 is 9. So that's my solution for that one. Now let's go ahead and try the bottom ones here. We're going to multiply each matrix by a term, and then we're going to add them. Okay, so let's go ahead and see if we can do that. So we have 3D, so we're going to take matrix D and multiply it by 3, by the scale of 3. So I have 3 times 7, 0, 3, 14, and 4, 6. 3 times 7 is 21, 3 times 0 is 0, 3 times 3 is 9, 3 times 14 is 42, 3 times 4 is 12, 3 times 6 is 18. And there we have it. Now let's go ahead and try 2 times E. So I'm going to take E and multiply it by 2. So I have 2 times 2, 4, 3, 5, and 6, 9. Go ahead and just multiply each term or each number on the inside by 2. 2 times 2 is 4, 2 times 4 is 8, 2 times 3 is 6, 2 times 5 is 10, 2 times 6 is 12, and 2 times 9 is 18. Finally, 3D plus 2E. Well, we'll go ahead and look. We already did 3D and we did 2E. Now we're just going to go ahead and add those two, and we can do that because they're both 3 by 2 matrices. Since they match the number of rows and the number of columns, we can go ahead and add them. So 21 plus 4 is 25. 0 plus 8 is 8. 9 plus 6 is 15. 42 plus 10 is 52. 12 plus 12 is 24. 18 plus 18 is 36. And there I just took 3D plus 2E. I had to solve those separately in the purple and the red, and then I just added those together. Since they were the same, I could add them. And that's it.